So let's move on to spectroscopy. So I'm going to, again, um, go to the home, and anything that we want to do in spectroscopy, we want to do in the spectroscopy technique. I should also probably remove the slit and change the energy back to 0. So another way that we can actually control the slit is from the microscope system. So if we go over here into the microscope UI, and you see that there's this little button with 3 dots. So if I left click on this button, and now it's possible for me to go back. So I'm going to manually change the energy loss to 0. And then I'm going to retract the slit or remove the slit. So slit out, energy loss 0. So we're at unfiltered state again. And then I want to go to the spectroscopy technique. So one thing that we do, that I haven't done yet, we're still in F10 mode. So if we want to do any spectroscopy, we need to be in EELS mode. It's really easy to change to EELS mode. We just left click on the EELS button in the microscope system palette. So click there, change the filter mode, and we're in EELS mode. So I want to just choose a low dispersion. So if I click on the same button that we used before to access the filter state dialog, now it has more spectroscopy centric functions. So I'm going to use the big aperture, which is 5mm round aperture, high SNR, and the lowest dispersion, which is 1.5 eV per channel. That gives us approximately 3000 eV energy range. And when we start a live EELS view, we need to kind of have a similar consideration that we want to be careful with the detector. So I'm going to go over to the right-hand side and look at the EELS palette. So I want to be in single EELS mode just for now, HQ mode, energy 0, and then I want to start at a very low exposure time. So the best way to do this for EELS is to choose an exposure time of 0, and the software automatically gives us the minimum exposure time. So for the continuum, the minimum exposure time is 0.1 microseconds. So now I have a very short exposure time. I'm good to start my EELS view. So we can see the 0 loss peak. The next thing to do is to go to auto exposure, and then kind of let the software determine what's the best exposure here. And then align ZLP. And then we want to do a auto tune. So the full width half maximum here is very broad. So the full width half maximum is our measure of energy resolution. So similarly, we have an autofocus function in spectroscopy mode. So I'm going to press autofocus. So a good thing to look at when we're running the autofocus is the full width half maximum of the 0 loss peak. It's kind of read out to us as that tuning goes ahead. So we saw that it started off with a full width half maximum of around 13 eV, which is really big. And now it's coming down kind of with each kind of tuning increment. So we expect it to land with this dispersion around maybe like 4 to 6 eV as our final answer. So we'll see what we get with the auto tune. Okay. So yeah, you can see that we started off 13 eV full width half maximum, and we've ended up with 6 eV-ish, 6.6 eV after the tuning. So it's really important to do these tuning steps. It really improves the performance of the system. So we hit OK. And now we have a sharper 0 loss peak, and we're saturating the detector a little bit. So you see yellow and red. We don't want that. So if I put the auto exposure back on, the software will recalculate what's a good kind of maximum single EELS exposure. And now we're in a good position. So I guess the last thing that we can do, so now that we have a good kind of single exposure, we can do a capture. So if I go to the bottom part of this palette and I go for a 1 second capture, captures a bunch of frames. So what's happening here is we are basically accumulating 1 second's worth of capture data in increments of that frame time that I just chose with my view time. The result gets put in this new analytical workspace. So here's our result. So we see strong zero loss peak, plasmon, and then if we use the splitter tool here, we can see a silicon L edge. And then if we go out, then we kind of get into the noise here. And we would need to kind of work a little to optimize acquisition around here. But this is a good kind of our first experience of how to use the software to acquire FTEM data and how to use the software to acquire EELS data.